In this video, we're going to look at a 7-mark exam question on integration. So it's giving you the differential of a curve. That's what f-x means. Or another way of representing this is if a curve is given in the form of y, then we can say that dy dx represents the first differential as well. You may have seen this format more commonly, but yeah, this is another way. It's asked you from this differentiated equation to then find f of x. So that means if this is the differentiated equation, if we integrate this, that will get you back to the function. So let's write that out first. The integral of f-x will get you back to f of x. You do also have to remember the plus c, but we'll take into account of that later. So our focus now is integrating this whole function here. In order to do this, we first need to put in a format where we can integrate it. To do that, we separate this fraction here into 3x squared over x to the power of a half plus 2 over x to the power of a half. I'm just going to remove this little bit of writing that I wrote here, but yeah, I think you guys got the idea. It's a 7-mark question. And we're able to do this because this way, the denominators are the same and the numerators would add up to 3x squared plus 2, just like we want. And then we're going to write a 5 plus at the beginning. Now we can focus on integrating each of these curves, but even before that actually, another step we could do, x squared divided by x to the half. Well, when you're dividing indices, you're taking away the powers. To take away a half is 1.5 or 3 over 2. So we can write this whole first term as 3x to the power of 3 over 2. So I'm just going to very quickly do that right now. So 3x to the power of 3 over 2. I'll show you a trick to integrating fractions as well. Sorry, fractional powers. Now, here, once again, it's not in a format where we can integrate it. So what we're going to do is we're going to bring, well, we can write this out as 2 times 1 over x to the half. And 1 over x to the half is essentially x to the minus a half, isn't it? So we can write this out as 2x to the minus a half. So let's do that right now. 2x to the minus a half. Great. Now that we've done that, we're going to integrate each of these individual terms. So the integral of, I might as well write this out, and I would recommend you write this out as well. I've noticed in a few of my videos I've just been not skipping a few steps, but not writing out every step. So I'll just do that right now. Great. When you integrate 5, you get 5x. When you integrate 3x to the 3 over 2, so I'll show you the trick now. You add 1 to the power, so that becomes 3x to the power of 5 over 2. But then you're dividing by that new power, aren't you? But what we know about dividing by fractions is it's the same as multiplying by the reciprocal of that second fraction. So you can write this out as multiplying by 2 over 5. 3 times 2 is of course 6, so we can write this out as 6x to the power of 5 over 2, keeping the denominator the same, so it's all over 5. Doing and applying the same thing to this third term, we'll have, well, minus a half plus 1 is a half. 2x to the power of a half divided by a half is the same as multiplying by 2 over 1, using that same logic. And that will give you 4x to the power of a half. So that's what the function of x is equal to, but you do also have to remember there's a plus c at the end. We know how to find the value of that plus c. How we do that is we use a coordinate that we know the curve definitely crosses through. And thankfully, it's told us a coordinate that the curve crosses through. That means that we can substitute y equals 2, or f of x, we can replace that with 2. And everywhere where there's x on the right-hand side of the equation, we can replace it with a 1. So 5x is 5 times 1. 6 times 1 all over 5 is 6 over 5. And 4 times the square root of 1 is just 4, and then plus c. Now, 5 plus 4 is 9. 9 plus 6 over 5, well, 6 over 5 is 1.2. Let's write all this out, because I'm doing so much mental maths. 5 plus 4 is 9. 6 over 5, we can write that as 1.2 plus c. 9 plus 1.2 is 10.2. We take away 10.2 from both sides, and we get minus 8.2 is equal to c. I know I'm mixing in fractions with decimals, but personally, I like to deal with decimals, but you don't have to do it like that. You can, and honestly, you're allowed to mix and match, but let's keep it consistent. Let's write everything in form of decimals now. So we have 5x, and then like I mentioned, 6 over 5 is 1.2. So I'm going to write as 1.2x to the power of 5 over 2, plus 4x to the power of a half, and then minus 8.2 for that constant. And that's the whole answer to the question. That's f of x in its simplest form. Hopefully that helped, and yeah, that shows how you can use integration to go from a differentiated equation to the function itself. Be sure to leave a like if the video did help, and subscribe, I'd appreciate a lot. Share the video too to friends who've done integration soon. Thanks for watching, I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.